Hello students, today we're going to talk about absolute value equations and inequalities. So the big new topic here is absolute value. And there are two cases of absolute value solving situations, and they are with equations and then with inequalities. And these two different, the difference between equations and inequalities is a lot. So be sure you separate those two concepts as you're listening to this recording and learning this material. In number one, you can see we have an absolute value and we have the equal sign indicating an equation. So to solve an absolute value equation, we branch into two parts. One is that x is equal to 5, and the other is that x equals a negative 5. So the second branch is to make the right side of the equation negative. Now when we make these two branches or these two columns of equations, note that we have absorbed the absolute value symbol, meaning it no longer exists. So we have two solutions, and they ask us to graph these solutions, which is really pretty simple, making sure that we put these two solutions on the number line, and then we put a dot over these two values representing that those are just two numbers as solutions to this original absolute value equation. Now I'm going to move down to number 4. Number 4, note here is your absolute value symbol. This expression is within it. We must isolate that absolute value information before we start branching into two equations without the absolute value symbol. So in order to do that, we need to come in here and divide this 6 off from in the front. So divide the 6 off of each side of this absolute value equation, so that now your absolute value equation has the absolute value term isolated or alone on the left side of this equation. Once it's alone and isolated, then you can branch into two equations without the absolute value symbol. So the right equation is the same equation, just pretty much eliminating the absolute value symbol. And the left is to take the right side of the equation and make it negative, just as we did in number 1. We now solve these two equations. The left equation, I would subtract the 4, and the negative 5 minus the 4 would be negative 9, and then I would divide by 2, resulting in a negative 9 halves, or if you want to, you can call this a negative 4 1/2, which is a mixed number. The right equation, I again would subtract the 4, and 5 minus 4 is 1, and then divide by 2, resulting in 1/2. So I have two solutions. One is the number 1/2, and the other is the number negative 4 1/2. So on a number line, 1, 2, so if this is 1 and this is 2, right in the middle would be 1/2. There's one solution. And negative 4 1/2, negative 1, negative 2, negative 3, negative 4, negative 5. So this is negative 4 and this is negative 5. Right down the middle would be negative 4 1/2. So there's the graph of your two solutions. And sometimes, not always, we'll write our solutions in what is referred to as set notation. So you have that open bracket, and then you just list your solutions in this set notation. So backing up to number 1, I could have written this, oh my goodness, that was a bad bracket. I could have written this as negative 5, 5. Now, not always are you required to put it in set notation, but just in case, there it is. Now, part 2 is college algebra material. So now what we have that differs from topic 1 is now not only do we have the absolute value, but now we have inequalities. And when you refer to inequalities, this is when you come in with the less than symbol and the greater than symbol, the less than or equal to and the greater than or equal to. Now, the less than symbol is worked differently than the greater than symbol in absolute value inequalities. So you need to divide this topic into two sections in your mind and note that there are two different methods of solving when you have the less than symbol with the absolute value versus the greater than. Personally, I think the less than is easier So I'm going to do the less than examples first. When I see the absolute value and the less than symbol, what I do is I convert this to what is called a compound inequality or a string inequality, which is one inequality with your numbers on the outside ends. So your 5 on the right and your -5 on the left. This is called a compound inequality. X is between 5 and -5, or X is less than -5 and greater, no, is less than +5 and greater than -5. This is really your solution, this string inequality, this compound inequality that I just wrote. So I'm going to go straight now to graphing it, and here's where you're going to see that this represents many solutions. So I need to make sure that my 5 is on my number line, and so is my -5. X is between -5 and 5, so I draw a line all the way across from the -5 to the 5, and the less than symbol indicates using parentheses. Now what this means is that every number under that line I drew is a solution to that original absolute value inequality. So numbers 1, 2, 3, 4, -1, -2, -3, -4, and all the fractions, 1, 1.5, 2.5, 3.5, a huge number of solutions to this original question. So they often want me to write this in interval notation. Well, interval notation takes your left number, which is a -5, and your right number, which is a 5, puts the comma between them, and then parentheses to indicate all values between -5 and +5 are solutions to that absolute value inequality with a less than symbol. Let's move down and do number 2. Now remember, if it's a less than symbol, I usually write it as a compound or string inequality. So I write my x plus 3 less than 7 and greater than the negative of that number on the right side, or the -7. This absorbs the absolute value. Notice the absolute value is not written anymore. So now I solve this string or compound inequality by subtracting the 3 off of all portions, leaving an x less than 4 and greater than a -10. Now once my x variable has no numbers around it, like it's not being x plus a number or x minus number or something times x, this is pretty much solved. So now I need to strictly graph it. So to graph this string or compound inequality, I need to make certain I get the -10 and the 4 on here. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. -10. So between -10 and 4 would be all of my solutions. The less than symbol gives parentheses, and there's the graph of all of those solutions to that original question. So in interval notation, my leftmost number is a -10. My rightmost number is a 4. I put a comma between them in parentheses, and this is my interval notation representing those numerous values which are my solutions. Now let's move to a different example. Let's go to number 4 with the greater than symbol. So an absolute value greater than symbol. This is very different from the less than symbol. In this example, I must have 2 branches. So one branch will write it as is without the absolute value, and the left branch will require 2 changes. Reverse the inequality from greater than to less than, and change the sign on the number to make it negative. 2 branches. So I write the 2 branches, and now I use the word or between them. Your x is isolated. It's not being added to a number or multiplied by a number. This is really your solution. So now to graph this, I need to get those 2 numbers on my number line, the +9 and the -9. X greater than 9 is to the right of the 9. And notice that the arrow on the greater than is to the right, so my graph is to the right. X less than -9, the arrow is to the left, so I start at the -9 and I go to the left of it. There is my graphical representation of my numerous solutions. Any number bigger than 9, 10,000, 1,000,005 is a solution to this original absolute value inequality. Anything to the left of negative 9, a negative 427, would be a solution to the original absolute value inequality. Now, to write this in interval notation, I have two regions. I have a right region on the right side, which is 9 to positive infinity. I don't like that graphic, but it's 9 to positive infinity. So this is 9 to infinity. This left region, the arrow pushing to the left here, is heading out to negative infinity. So this is negative infinity to negative 9. I wrote that horribly. Let me rewrite that. This would be negative infinity to negative 9. So you have two intervals which are containing all of your solutions. So to put these two intervals together, we put this capital U in the middle, which is really the union symbol. And this is your interval notation for the solutions to the greater than absolute value inequality. Number 6 is your most difficult one on the page, so let's tackle it. Okay, again, take note, here is your absolute value information. It must be alone before I can complete the solving process. So the first thing I do is divide off this 5, so my absolute value term is alone or isolated with no number in front of it. So now, to take that absolute value greater than symbol, like number 4, an absolute value greater than symbol, I have two branches. One branch is to write it as is, eliminating the absolute value symbol. The left branch is to write it, reverse the direction of the inequality, not greater than now, but less than, and make that number to the right side negative. Now I don't have an absolute value symbol anymore. I need to solve each of these branches. So my left branch, I need to subtract 5 off of each side. So this would be 3x less than a negative 9. And then when I divide by the 3, I get x less than negative 3. My right side, or the right branch, I subtract 5, which makes 3x greater than negative 1. And then when I divide by 3, x is greater than a negative 1/3. I put the word or between here, and this is my solution. Now I need to graph it, and I need to write it in interval notation. So draw a number line, making sure that I get these two numbers on here, the negative 3, 1, 2, 3, and the negative 1/3. It's kind of estimated in there. So x greater than a negative 1/3, that arrow is to the right, so I go to the right of the negative 1/3. X less than a negative 3, the arrow is to the left, so I go to the left of the negative 3. Now I just took note of the fact that this is supposed to be, it started greater than or equal to, so this should be a greater than or equal to, which means I should have a greater than or equal to, and over here a less than or equal to. Now what that equal does, which is kind of nice to put this emphasis in here by adding that to the inequality at this point, what the equal symbol does, added to the inequality, is it requires this to not be a parentheses but a square bracket. And what the square bracket means is you actually include that number in the solution. So the square bracket, when you have a greater than or equal to, or a less than or equal to in your solving process. So in this case, I have two regions of solutions, so I'm going to have two intervals. The right side interval is a negative 1/3 to infinity, and that's a negative 1/3. I'm going to kind of emphasize that a little more. A negative 1/3, and I get a square bracket and a parentheses. The left region is going to be from negative infinity to negative 3 with a square bracket on the negative 3 and the U, or the union symbol, between them, and this is your interval notation. Now just a quick note, when you're writing interval notation, infinities can only have parentheses on them. So never try to put a square bracket on an infinity. It's always a parentheses. I know this was a little more difficult material, especially so early in the semester, but just do the best you can. Make certain you separate the less than from the greater than methods with these absolute values whenever you go into this. So hang in there, give it some work in your homework to practice it and to greater understand it. And I hope to see you in my next recording. Have a great day.